try. Hi, I'm Zahid.
Hi, I'm Jah. Hi, my name is Farah. Hi, I'm Atika. Hi, I'm Iman. Hello, my name is Wahida. Hi, I'm Izni. Hi, I'm Shaz. This video is about colloid and surface chemistry.
Hello everyone, in this video we are going to learn about colloid. In my part, I will explain to you guys about colloid, true solution and suspension. So first of all, let us get to know colloid in detail. So, what is colloid? Do you have any idea? Colloid is defined as a dispersion of particles of one substance known as dispersed phase throughout the dispersion medium made of another substance. Two main things in colloid are dispersed phase and dispersion medium. First phase is the substance which is dispersed as very fine particles. Meanwhile, the substance present in larger quantity is called dispersion medium. The example of colloids are beaten egg white, cheese, paint, jelly, toothpaste, and also mold itself. Now, let's move to true solution and suspension. True solution is homogeneous solution which the solute particles have diameter less than 10 to 9 nanometer. The particle of true solution cannot be filtered through filter paper as compared to colloid, so not visible to our naked eyes. For example, solution of sugar in water. Suspension is a heterogeneous solution which the particle size of one or more components is greater than 1000 nanometer. The particles of suspension are big enough to be seen in our naked eyes. One of the examples of suspension is mud dissolved in water. So we already know about colloid, true solution and also suspension. Some comparison in order to get a clearer view of this string. We look at difference between colloid, true solution and heterogeneous. In terms of size, true solution have 0.1 to 1 nanometer, which is ion and small molecules. For colloid, 1 until 100 nanometer, and for heterogeneous or suspension, more than 100 nanometer. Stability, true solution have stable under gravity. For colloid, less stable, and heterogeneous or suspension, not stable, easily settled out of water, will form precipitation. In terms of homogeneous, true solution is a homogeneous solution. Colloid quite homogeneous, and heterogeneous or suspension heterogeneous. In terms of transparency, true solution are transparent, colloid translucent, and heterogeneous or suspension are opaque. Of tinter, true solution no tinter effect, while colloid have tinter effect, and heterogeneous or suspension no tinter effect.
We already know what colloid is. So now, let's move on to the types of colloids. Do you have any idea how many types of colloid do we have? Colloid are actually divided into two types, which are lyophilic colloid salt and lyophobic colloid salt. Let us take a look at lyophilic colloid salts first. Lyophilic colloids are liquid living colloids. Lyo means solvent and philic means living. Since the salts like solvent, therefore it will have an intermolecular attraction between the dispersed phase and dispersion medium. Next, it is also a thermodynamically stable colloid dispersion. This is due to the strong attractive forces between the particles and the dispersion medium, which is the hydrogen bonding. In addition, as it is thermodynamically stable, the salt is not easily coagulated. Now, let's move on to lyophobic colloid salts. Lyophobic colloids are liquid heating colloids. Lyo means solvent and philic means heating. Since the salt fills the solvent, therefore there will be no intermolecular attraction between the dispersed phase and the dispersion medium. It is also thermodynamically unstable compared to separated states. Therefore, Dispersion can be formed with mechanical energy input such as mixture, colloid, mill, and ultrasound generation. The ability of the lyophobic salt depends on the charged particle as the like charge will repel each other. These properties can reduce coagulation. Some of the examples of lyophobic colloids are gold, silver, and sulfur salts. Okay, we already know what the two types of colloid salts. Now, for a clear understanding, let us see the table of comparison of lyophilic salts versus lyophobic salt. For lyophilic salt, solvent loving, while for lyophobic salt means solvent hating. Lyophilic salt interacts strongly between dispersed phase and dispersed medium, while for lyophobic salt, there are no interaction between dispersed phase and dispersing medium. Lyophilic salt has high viscosity of dispersing medium and easily set to gel. For lyophobic salt, viscosity is no different from pure liquid and do not set to gel. Lyophilic salt have no or little charge on particles, and particles carry positive or negative charge for lyophobic salts. Particles migrate to either anode, cathode, or not at all in lyophilic salt, while for lyophobic salt, particles migrate to either anode or cathode. Lyophilic salt precipitated by high concentration of electrolyte, while for lyophobic salt precipitated by low concentration of electrolyte.
Alright, next I will explain on the preparation of colloidal solution. It is not easy to prepare the lyophobic colloid salts practically as they have no affinity of the dispersion medium. Special methods are required for the preparation of the salts. So, what are the special methods? There are actually numbers of special methods used for preparation of lyophobic salts, which can broadly divided into two, which are dispersion methods and condensation methods, or also known as aggregation methods. In my part, I will only explain on the dispersion methods. In dispersion methods, the bigger particles of any substances are broken down into small particles of colloidal size. The small particles obtained are stabilized by adding some stabilizing agents. Dispersion methods can be divided into three types, which are mechanical dispersion methods, baptization, and electrical dispersion method, which also known as Brady's arc method. Let us start with the mechanical dispersion method. In this method, the large particles of the material whose salt is to be prepared are broken down in a machine called colloid mill. Colloid mill consists of two heavy steel discs separated by a little gap, and it can be adjusted according to the particle size desired. A suspension of the substance in water is added into the mill. The particles present in the suspension are grinded to form the particles of colloidal size and also get dispersed in water to form a salt. Final dispersion can be obtained by adding an inert diluent which prevents the colloidal particles to grow in size. Some of the examples are the usage of glucose as diluents in the preparation of sulfur salt. Next is the baptization. Baptization is the method of breaking down the freshly prepared, precipitated particles into the particles of colloidal size. How is this done? It is actually done by adding suitable electrolytes, and the electrolytes added is called baptizing agent. Finally is the Brady's arc method. This method is used for the preparation of salts metals such as gold, silver, and platinum. In this method, two electrodes of the metal whose salt is to be prepared are immersed into the dispersion medium, and an electric arc is produced by passing a high voltage current. The dispersion medium is cooled by surrounding it with a freezing mixture. Due to the heat produced from electric arc, the metal starts vaporizing and the vapor condenses into the cold dispersion medium to form the particles of colloidal size. On the addition of alkaline to the conductivity water helps to get a more stable colloid.
We have already covered on the first method of preparation of colloidal solution. So now, let us move on to the second preparation method, which is condensation method, or also known as aggregation method. Condensation method is an indirect method of preparation of colloidal solution. The material from which the salt is to be prepared are originally present in true solution as ion or molecule. As a result of chemical reaction between them, particles of colloidal size are obtained. Condensation method can be divided into 5 different types, which are double decomposition, solvent exchange, hydrolysis, oxidation, and reduction. Let us start with double decomposition method. This method involves the passage of hydrogen sulfide through dilute solution of arsenious oxide or mercuric cyanide yield salt of arsenious or mercuric sulfide respectively. Some of the examples are barium sulfate salt or silver halide salt. Next is solvent exchange. In this process, no actual chemical reaction takes place when a relatively concentrated solution of a substance is added to a large volume of liquid in which it is very soluble. Particles of colloidal size results under experimental condition. For example, salt of gum mastic, sulfur, or phosphorus can be obtained by pouring alcoholic solution into a large excess of water. The third method is hydrolysis. This method is a form of double decomposition in which water is one of the reactants. It is used to obtain salts of oxide or hydroxide of weakly electropositive metal such as iron or aluminium. For example, a salt of ferric oxide is prepared by adding a small quantity of ferric chloride to boiling water. Hydrolysis occurs and ferric hydroxide and hydrochloric acid is produced. For example, a salt of ferric oxide is prepared by adding a small quantity of ferric chloride to boiling water. Hydrolysis occurs and ferric hydroxide and hydrochloric acid is produced. The former remain in colloidal state and the latter is removed by using dialysis. Next, let's move on to oxidation. A very good illustration of this reaction is the formation of sulfur salt by oxidation of aqueous hydrogen sulfide solution with air or sulfur dioxide. For example, selenium salt may be similarly prepared by oxidation of solution of hydrogen selenide. Last but not least is reduction method. This method is particularly valuable for the preparation of metal salt. It is of historical interest as the earliest known gold salt were obtained by this method. The reducing agent commonly employed are hydrogen, phosphine, carbon monoxide, and also phosphorus. For example, gold salts are readily obtained by reduction of chloric 8 solution containing a trace of potassium carbonate by formaldehyde.
We have already covered on the preparation of colloidal solutions. Next, let us take a look at the purification of colloidal solution. The most commonly used method for the purification of colloidal solutions are dialysis, electrodialysis, ultrafiltration, and ultracentrifugation. Let us take a look at each method starting from the most familiar method, which is dialysis. Dialysis principle is based upon the fact that colloidal particles cannot pass through a parchment or cellophane membrane, while the ions of the electrolyte can pass through it. Impurities slowly diffuse out of the bed, leaving behind the pure colloidal solution. Next is electrodialysis. The ordinary process of dialysis is slow. Therefore, in order to increase the process of purification, the dialysis is carried out by applying electric field. This is why it is called electrodialysis. Let's move on to the third one, which is ultrafiltration. In this method, salt particles are directly passed through ordinary filter paper because their pores are larger than the size of salt particle. Pores of the ordinary filter paper are made smaller by soaking the filter paper in a solution of gelatin of collodion and subsequently hardened by soaking it in formaldehyde. The treated filter paper may retain colloidal particles and allow the true solution to escape. The filter paper is known as ultrafilter, and the process of separating colloids by using ultrafilter is known as ultrafiltration. Last but not least is the ultracentrifugation. In this method, the salt particles are prevented from setting under the action of gravity by kinetic impacts of the molecule of the medium. The setting force can be enhanced by using high-speed centrifugal machine having 15,000 or more revolutions per minute.
The machines are known as ultracentrifuges. We are going to focus on the colloidal properties. There are 5 main colloidal properties, which are Tyndall effect, Brownian movement, electrophoresis, coagulation, and adsorption. In my part, I will explain on the Tyndall effect, Brownian movement, and electrophoresis. Let us begin with Tyndall effect. So, what is Tyndall effect? Tyndall effect is caused by reflection of light by very small particles in suspensions in a transparent medium. Tyndall effect will actually increase linearly with the concentration of the colloidal solutions. The process is when a beam of light is thrown against a colloidal solution. The path of the beam is illustrated as a result of the scattering of light by the particles, and a blue cone, which is known as Tyndall cone, is observed. Next is Brownian movement. The colloidal particles in solutions are in a state of constant and rapid zigzag motion. It is called as Brownian movement. This is due to the random collisions with the molecules of the suspending medium, other particles, and the walls of the containing vessel. The higher the temperature of the colloidal solutions, the more vigorous is the movement of the molecules. Therefore, it will increase the Brownian movement. Lastly is electrophoresis. In this method, the particles of a colloidal solution possess either a positive charge or a negative charge. If a colloidal solution is placed in a U-tube and a potential difference applied at its two ends, the charged particles are seen to move towards the opposite electron. This movement of the charged particles under the influence of electric field is known as electrophoresis.
Another colloidal properties are coagulation and adsorption. Let's know about coagulation first. Coagulation is addition of electrolyte, which is a substance that produces an electrically conducting solution when dissolved in polar solvent, such as water. Therefore, this addition of electrolyte will cause the precipitation of colloidal particles because the charged ion of the electrolyte neutralize the charge on colloidal particles. Next, as for adsorption, is a process involving of bulk penetration of gas or liquid into the structure of the solid, which is usually associated with an increase in bulk volume. To make it more clear, adsorption can also be understood or known as a process in which a substance becomes attached to the surface of solid or liquid. Besides, this process must be distinguished from adsorption, in which the substance becomes distilled throughout the solid or liquid. As example, activated charcoal absorbs gases like carbon dioxide (CO2), sulfur dioxide (SO2), chloride (Cl2), and many more. Another example, when charcoal is added to acetic acid solution and shaken it vigorously, it will absorb acetic acid. For your information, adsorption can be happen because of several factors. First factor affecting absorption is nature of absorbate and absorbent. Next, the surface area of absorbent. Besides, absorption can also occur because of activation of absorbent. And lastly, it is because of experimental condition, as example, temperature and pressure.
Next, in my part, I will explain on the types of adsorption. Do you know that we have two types of adsorption, chemical adsorption and physical adsorption? Now, let us start with chemical adsorption. When the force of attraction existing between adsorbate and adsorbent are chemical force of attraction or chemical bond. The process is called chemical adsorption. It takes place with formation of unilayer of adsorbate on adsorbent. It has high enthalpy of adsorption, therefore it can take place all temperature. With the increase in temperature, chemical adsorption first increases and then it will decrease. Meanwhile, for physical adsorption, it is when the force of attraction existing between adsorbate and adsorbent are weak, when the wall force of attraction. Physical adsorption takes place with formation of multilayer of adsorbate on adsorbent. It has low enthalpy of adsorption. It takes place at low temperature below boiling point of adsorbate. As the temperature increase in process of physical exertion decrease. Okay, now for a better understanding, let us make some comparison between these two types of chemical exertion. From the table, you can see that for physical exertion, heat of exertion less than about 10 kilocalorie per mole, while for chemical exertion, heat of exertion greater than about 20 kilocalorie per mole. Next, exertion is appreciable only at temperature below the boiling point of the adsorbate for physical exertion, while for chemical exertion, exertion can occur at high temperature. The incremental increase in the amount adsorbate increase with each incremental increase in pressure of the adsorbate for physical exertion, while chemical exertion, the incremental increase in the amount adsorbate decrease with each incremental increase in the pressure of the adsorbate. The amount of absorption on the surface is more function of the adsorbate than the absorbent for physical absorption, while for chemical absorption, the amount of absorption is characteristic of both adsorbate and absorbent. No appreciable activation energy is involved in the absorption process for physical absorption, while for chemical absorption, an activation energy may be involved in the absorption process. In physical absorption, there are multi-layer absorption occur, while for chemical absorption leads to at most a monolayer.
Isotope is an equation which relates the amount of substance attached to the surface, its concentration in the gas phase at a fixed temperature. There are two types of isotope. First is Lamia for monolayer absorption. Second, BET for multi-layer absorption. Let's move to first type of isotope. In 1916, Ibrahim Lamia published a new model isotope for gases adsorbed to solids. It is a semi-empirical isotope derived from a proper kinetic mechanism. Lamia isotope describes a single layer absorption which the volume of gas molecule absorbed at a certain pressure. This isotope based on different assumptions, one of which is dynamic equilibrium exists between adsorbed gases and the free gases molecules. There are four assumptions of Lamia isotope. First, the solid surface of adsorbed is uniform sides are equivalent. Every side have same energy. Adsorbed molecules do not interact, therefore adsorption is localized. All adsorption occur through same mechanism. And the last but not least, a maximum of monolayer can be adsorbed, and adsorption cannot proceed above monolayer coverage. Brunner, Inman and Taylor or BET isotope is the second type of isotope. It's used to explain the multi-layer absorption that occur especially in physical absorption. The absorption process can be described in terms of attachment of molecule directly on solid surface or the attachment of molecule the site already occupied by adsorbed molecule forming the second layer. BET isotope also describe the ratio of the volume gas that is adsorbed and the volume that will produce a single layer. In addition, the blow-up layers can continue until as the gas pressure approaches the vapor pressure of the gas. The adsorption has reached the stage where the surface could be described as wet, and due to vapor condition as the gas pressure increase. This video is about Colloid!
Aku nak masuk.
Boleh ke?
Oh, aku